Obviously, there are methods for finding definite integrals, like, for example, use substitution or integration by parts. But a lot of times, one thing you can apply even before actually doing those integration methods in order to kind of simplify the problem you have are these definite integral properties. So in today's video, I wanted to show you a portion of one of my recent live streams, which I'm doing every Monday night at 5 Pacific, where I went over how to use these definite integral properties in order to simplify an expression into a single integral. Not only is this an example of a type of problem you might run into while taking integral calculus, but these same methods can actually be applied in more complex integration problems to simplify your problem before actually applying integration, which can really help make your life a lot easier. And these formulas are all coming from my integral calculus cheat sheet or my calculus 2 study guide. If you want to check that out, there is a link down in the description below and in the pinned comment as well, so be sure to check that out. And without further ado, let's go ahead and jump on into the example. We're going to write basically this expression that we have here as a single integral. So I have done another problem on my channel kind of similar to this, but this one is a little bit different, and I just wanted to kind of give you a little bit of variety and show you another kind of similar example to how we can apply these definite integral properties to simplify an expression like this down into a single integral. So in this case, it is a little bit more theoretical, right? We don't actually have a function for f of x or a function for g of x, but it really does illustrate something useful about using these definite integral properties, because if we did actually have some function for f of x and g of x, we could use these definite integral properties to combine this expression of three separate integrals down into one single integral, which hopefully, ideally, would be easier to solve than solving three separate integrals. So that's kind of the helpful thing about these definite integral properties. As we kind of work through these, I'll show you exactly which properties from my Calculus 2 study guide we're actually going to use. And the first one we're going to start out with is, well, this is going to kind of use a couple all at once, I guess I should say. But really what we're going to be doing is to kind of keep in mind that if you have an integral of the same function, so in this case, let's just start by looking at these first two integrals here. So we'll start with this one and this one. We have the integral from 1 to 3 of f of x dx minus the integral from 2 to 3 of f of x dx. We can kind of think of this in a couple of different ways, but since we have the same function that we're integrating, right, both of these integrate f of x, these definite integral properties tell us how we can kind of manipulate the bounds of our integral. So there's a couple ways you could kind of think about this. The most intuitive would be probably to, instead of thinking of this as the integral from 1 to 3 of f of x, think of it as, and this is one of the properties on my study guide, is think of it as the integral from 1 to 2 of f of x dx plus the integral from 2 to 3 of f of x dx. And the reason why we want to do this is because now if we have this minus the integral from 2 to 3 of f of x dx, notice these two match up with each other exactly. We have the integral from 2 to 3 of f of x dx minus the integral from 2 to 3 of f of x dx. So as a result, if you have something minus itself, it's just going to cancel out. So these two this chunk of this first integral is going to cancel with the second integral we started with. And then we're still going to have the same thing over here, 16 times the integral from 1 to 3 of g of x dx. So now what we want to kind of think about is what we can do with this integral. And actually, I'm sorry, I made a mistake here. This was supposed to be a 2 right here. This integral over here should go from 1 to 2 of g of x dx. Wrote the problem down wrong. All right, there we go. So now that we have this integral here, let's kind of think about this last piece that we had over here first. One thing to kind of notice, first of all, is the bounds of this integral over here are the same as the bounds of this integral over here, which is nice because that should hopefully kind of give us a clue of which integral properties we might be able to use. And the one I'm referring to specifically is if we have the integral from a to b, f of x dx, plus the integral from a to b of g of x dx, this can simplify down into the integral from a to b of f of x plus g of x dx. So this is just something that is, pretty nice about definite integrals. If you have the same bounds on two separate integrals, you can combine them by simply adding, or if this was a minus sign, we could subtract whatever those two functions were. So based on the fact that we have the same bounds for this integral and this integral that we have remaining, if we can manipulate this last integral over here to get it so that we just have the integral from 1 to 2 of something, we can then combine that with our first integral over here using this property. So the question is, how can we get this to just be the integral from 1 to 2 of something rather than having this 16 out here like this? Well, another one of the properties that's on my study guide that I showed at the beginning of the video, and I can show that again here, is, and I don't think you can see my cursor now with this, but if you look at on the left side column, the third one down tells us that if we have the integral from a to b of some constant c times f of x dx equals some constant c times the integral from a to b of f of x dx. So basically what that tells us is if we have a constant being multiplied by an integral, we can move it into the integral and multiply it by whatever was in the integral, or vice versa. We could also do the opposite. So if we had a constant times our function within the integral, we could pull the constant out. Well, in this case, we're going to want to put it in. So what we can do is we can make this 16 times g of x dx. So now we have, kind of what we wanted to hopefully get, which is the integral from 1 to 2 of f of x dx plus the integral from 1 to 2 of 16 times g of x dx. So now what we can do, now that they have the same bounds, we just have the integral from 1 to 2 of this function here plus the integral of 1 to 2 of this function here. We can now apply this property over here, which tells us that this is going to combine down into the integral from 1 to 2 of whatever this function is, so f of x, plus whatever this function is, 16 g of x. So now what we've done is we've simplified these three separate integrals that were being added and subtracted together down into one single integral. Now we would just have to find the integral from 1 to 2 of f of x plus 16 g of x dx. And I'm sorry, I just realized I had some of this covered up over here on the left. So now you can kind of see this property a little bit better that we just applied here. Well, I hope you found that video helpful. If you did, do me a favor and hit that like button down below. Hit subscribe while you're down there too, and that bell icon so you're notified of all my new videos. And when I'm going live, like I said, I've been doing a weekly live stream every Monday night at 5 Pacific, 8 Eastern time, so hope to see you there next week. And if you want to check out some more integration videos, I have made plenty of others. Go ahead and click on one of those videos over there, and we'll see you on Monday.